All right, so let's go through each of the Lewis structures you drew and determine we can do both again, electron geometry and molecular geometries. So I'll probably give you both, but if you want, go ahead and write down just the molecular geometry. I think that's more important than the electron geometry. All right, starting with CCl4 carbon tetrachloride. All right, we have 4 bonds on the central atom and no lone pairs. So this is like AX4. So 4 bonds, no lone pairs in the central atom. The molecular and electron geometry are tetrahedral. So again, if there's no lone pairs of electrons in the central atom, the electron geometry and molecular geometries will be the same. If there are lone pairs of electrons on the central atom, then the molecular geometry will be different than the electron geometry. All right, NF3 is our next one there. We have this time 3 bonds and 1 lone pair, so 4 electron groups. So the electron geometry is tetrahedral. However, the molecular geometry is trigonal pyramidal. So this is AX3E, trigonal pyramidal. H2SE, be careful. It looks like, if you draw the Lewis structure like this top one here, it looks like it is linear. It looks like all the bonds are in a straight line. So don't base the geometry on how you drew the Lewis structure. Likewise, the NF3, this first Lewis structure, doesn't really show the trigonal pyramidal geometry, and that's why I like to draw it this bottom way. Same thing here with H2SC. I prefer this bottom Lewis structure because that shows better, more accurately, the geometry of this molecule. Has a tetrahedral electron geometry, however, the molecular geometry is bent, AX2E2. All right, so for the 3 across the top, F2, O2, and N2, anytime you have a molecule or polyatomic ion that consists of just 2 total atoms, where there is no central atom, we can still give it a geometric shape. The molecular geometry, or geometric shape is another term for that, is linear. So F2, O2, N2, those are all linear molecules. All right, BF3, we have 3 bonds and no lone pairs. So the molecular geometry of this is trigonal planar. SeCl6, we have 6 bonds and no lone pairs in the central atom. This is AX6, so this would be octahedral. PF5, we have 5 bonds, no lone pairs. This would be trigonal bipyramidal. NF4 plus, so we can assign molecular geometries to polyatomic ions as well. So we have 4 bonds, no lone pairs. This is tetrahedral. SO3, now be careful with this one. We're going to treat, in this case, the double bond as just 1 bond. It's 1 bond, it just consists of 2 shared pairs of electrons. So we have 3 bonds and no lone pairs on the central atom. SO3 is trigonal planar. Sulfites, 3 bonds, 1 lone pair. So it's a tetrahedral electron geometry. However, the molecular geometry or geometric shape is trigonal pyramidal. BeCl2, 2 bonds, no lone pairs on the central atom. This is linear. Now for the C2H6, we can determine geometry around each carbon in that hydrocarbon. So if we look at just the carbon, say on the left, it has 1, 2, 3, 4 bonds. So 3 bonds to hydrogen, 1 bond to carbon. So each carbon in this compound, in this molecule, would have a tetrahedral geometry. So tetrahedral for each carbon. In C2H6, we don't, though, give the molecule as a whole a geometry. This is a hydrocarbon chain, so we're going to look at just each carbon in that chain. Xenon tetrafluorides, XeF4, we have 4 bonds and 2 lone pairs. So this has an octahedral electron geometry because there's 6 electron groups on the central atom. This is AX4E2, 4 bonds, 2 lone pairs. This is square planar. Iodine trichloride, ICl3, we have 3 bonds and 2 lone pairs, so 5 electron groups total. So this would have a trigonal bipyramidal electron geometry. However, because we have 3 bonds and 2 lone pairs, the molecular geometry of this is T-shaped. And lastly, SO2. Again, we're going to treat that double bond as 1 bond. So we have 2 bonds and 1 lone pair. So this has a trigonal planar electron geometry. However, the molecular geometry is bent. So mention at the beginning of this unit that we will use Lewis structures for a number of things. One, as we just saw here, is to determine the molecular geometry or geometric shape of the molecule. We will also use Lewis structures to determine the polarity of the molecule, and we will do that in our next or subsequent lessons. All right, thanks for watching.